Good morning. So this is a video on translating quadratic functions. It's actually transforming quadratic functions. It's all about moving various quadratic functions around the graph. This is a review from the functions unit. We've already gone through these transformations, but this is specifically to quadratic functions. The objective is, by the end of this video and by the end of class, you'll be able to graph and describe the transformations of quadratic functions. So first we need to remember the parent function for a quadratic function, which is x squared. So if we start off with our normal points, -2, -1, 0, 1, and 2 for our x, when we plug them in, we get our y values, which are going to be -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So then we plot them, and then we can graph our quadratic. So that is our parent function. But there are basically 3 different moves that we'll do. Okay? Now there's 2 forms of quadratics. There's the vertex form, and then there's the standard form. Standard form we're going to go into in our next video. We're going to just show vertex form. Now you should be familiar with the A, H, and K, but let's review. Okay, the H or the K moves it vertically. That means up and down. Okay, it is adding and subtracting outside the parentheses. So if it's plus K, it moves the graph up. If it's minus K, it moves the graph down. Remember, those numbers are outside the parentheses. The H is inside the parentheses, and it's always the opposite. So that's why you'll see a minus H in there in the parentheses. So if it says plus H, it moves the graph left. If it says minus H, it moves the graph right. Here are a couple examples. So x squared plus 4. So I'm going to start off with my parent function, okay, the functions that I got. So those are my 5 starting points. And then I have to identify, what does that plus 4 mean? That plus 4 is outside parentheses. I don't see any parentheses, so it's outside. So it's going to move all of those points up 4 to new positions. So all I do is I just count them up 4. I then can graph my parabola right there. The next example is x plus 3 inside the parentheses squared. So again, I start off with my parent function. That's always what we're going to start off with. And then I identify that it's inside, so it's plus, and it's going to move it left 3. So I'm going to take all of those points, and all I'm going to do is move them left 3. I position them, and then I can draw my parabola. So the other transformations are dilations and reflections. So a dilation makes a graph wider or narrower, and a reflection just flips a graph. So that's the A in front of the parentheses, or in front of that x, that A times x minus h squared plus k. So the A affects if it's narrower or wider. If A is bigger than 1, the parabola will get narrower. It'll shrink. Okay. If A is a fraction or a decimal, it's going to get wider. It's going to open up. If A is negative, the parabola, if it's opening up like this, it's going to flip down. Okay. It's going to open down. But the biggest thing with the A is that it multiplies the y values of the parent function. So that's the trick with this, is it's multiplying the y values of the parent function. So when we get into our next example, okay, the 2x squared, you notice that the 2 is from in front of the x squared. That means it's the A. So what I'm going to do is I'm going to start off with my parent. And then the A always multiplies my y values. So I'm going to just take my y values and I'm going to multiply them all by 2. It's going to get narrower. It's going to rise twice as fast. So I multiply them. It's going to come out to be 8, 2, 0, 2, and 8. So those are my new y values. My x values do not change. Okay, so I ignore all of the other stuff, and now I just plot -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. You'll notice that the blue are now my new function, and I can graph my parabola. So you notice that it's narrower. In my next example, -1/2 x squared minus 3, there are actually two movements. Okay, but first thing is I plot my parent function. The -1/2 x squared, the -1/2 is my a value because it's in front of the x. So all that does is it multiplies the y values. Okay, it's going to get wider because it's a fraction, and it's negative, so it's going to flip. After I do all of that, then it's going to be moved down 3. So that's how I am describing the transformation. So I multiply all my y values. I get new y values. So -2, -1/2, 0, -1/2, and -2. So I plot these new x and y coordinates, and I get those blue dots. Now I then have to do the -3. So the -3 just moves all of those points down 3. I get these new points, and I can draw my parabola that's a little bit wider, down 3 and flipped. In example 5 and 6, there's a combination of things. So you notice that the -4 is inside parentheses and the -5 is outside the parentheses. So there's two movements. Okay, I'm going to plot my parent function, and then I'm going to identify my transformation. So the -4 moves things right 4, and the -5 moves it down 5, because the -4 is inside the parentheses and the -5 is outside the parentheses. So I'm going to move all the points right 4, down 5. I have these new points. I can then graph my parabola. In the next one, there's actually 3 transformations. So again, I'm going to start off with my parent. The -1/2 is outside the parentheses. It's in front of everything. So that's going to be my a value. So that's going to multiply my y values. It's going to make it wider. Because it's negative, it's going to flip. And then after I make it wider and flip, I then have to move it left 3 and up 6 based on where the +3 and the +6 are. So the first thing is I multiply all my y values by -1/2. I get my new ones. I'm going to plot that in green. Okay. Now I move things left 3 and up 6, and I get my final points, and I can draw my parabola. So those are the most complicated graphs that you're going to be doing. But practice the graphs on the next page. Remember, A multiplies the y values, H moves things left or right, Y moves things up or down.